And so here is another example of a polynomial inequality. This one's kind of nice because it's already in factored form. But again, the same main steps are necessary for solving, okay? First, we're going to find the zeros. Now, the zeros are going to be much simpler to find on this one. The zeros come from each of these factors. In fact, two of them I really don't have to do much with. This one here, the 0 is 2, and here the 0 is -3. Those seem pretty obvious. This one here, if you were to take 4 minus x and set it equal to 0, add the x to both sides, 4 is going to be the other 0, right? It's the number that when you plug it in, gives you 0 as an output. So these are the three zeros, 2, 4, and -3. Okay, so I found my zeros. Now I have to make the sign chart. Okay, so the sign chart is again going to be on a number line. I've got to put these three numbers in order. I don't have to get too specific on the relative distance from each other. As long as they're in the correct order is going to be good enough. So -3, 2, and 4. And I'm going to split this off. And now I can go through and plug in some values for each of these intervals. So let's start off on the far left here. I like to work left to right, but again, you can pick whatever you want. So if I start off on the left, well, let's see, maybe I'll throw in a negative. Sometimes 10 is kind of nice, even though it's out there kind of a little bit further, maybe -10 will work. If I pick a number in between -3 and 2, well, 0 is a good number, that's in there, right? 1 would work, whatever. Between 2 and 4, I'll throw 3 in there. And of course, you could throw decimals or fractions in. It just so happens that all of my intervals contain nice integers, so I'm just using them. And then out here on the right, maybe I'll throw a 10 in just to see, so you can see what happens when I throw bigger numbers in. Okay, so let's try -10 first. And again, I'm going to go to my factored form and just start plugging those in. One thing that's going to be, that kind of stands out to me is that this last factor is squared, which means it's always positive, right? I mean, or 0, but it's only 0 at that point, so we already accounted for that. Everywhere else it's going to be positive, okay? So this factor is positive. I don't really need to factor it in, literally, because it's not going to affect the sign of the answer, the output, right? No matter what these two give me, when you multiply them by this positive factor, it's not going to change anything. So if I just account for these two, the first two, then that last one, is unnecessary. So I'm just going to look at those two factors then. So I know then this guy right here is positive. Just make a note of that. So here, if I plug in -10 minus 2, well, that's a negative number. Actually, I'm going to do this below. So that's a negative. And then 4 minus -10. Well, the double negative when I plug in the -10 will make that a plus. 4 plus 10 is positive. Okay. So I have a negative times a positive when I put in the -10. That combination gives me a negative product. So I have all negative outputs on that left side. Okay, now at the 0, if I plug in the 0, 0 minus 2 is negative. 4 minus 0 is positive. And so there the product is also negative. Okay, all the outputs in this second interval will be negative. And then between 2 and 4, I plug in the 3. 3 minus 2, that's positive. And 4 minus 3, that's also positive. And so the product is positive. So every output from that interval will be positive. And then finally I plug in the 10. Well, 10 minus 2, 10 minus 2 is positive. And 4 minus 10, well, the bigger one is negative there, so that's going to be negative. And that combination is going to then be negative, interestingly. So everything out on the right here is negative. Now, I want an interval that makes the polynomial greater than 0, or in other words, positive. That's what we're looking for. And so that gives me only one interval this time, right here between between 2 and 4. Okay, so my final solution, and again, I'm going to exclude the endpoints because there's no equals in my original inequality. So my final solution then is simply the interval 2, 4. That's my solution, okay? Now just to relate this quickly to the graph, if I were to look at the graph of this function, I know some things. First of all, at the x-intercept of -3, the graph touches the x-axis because of the even multiplicity, but at the other two, it doesn't. It goes through. Also, this is a 4th degree polynomial, right? 1, 2, 3, 4. 4 degrees there. So a 4th degree polynomial. It also has a leading coefficient that is negative, which is interesting, right? I've got a positive leading coefficient here, a negative leading coefficient on the x, and a positive. That makes a negative leading coefficient. So negative leading coefficient, 4th degree. So I know my graph is going to be kind of an M shape, right? 4th degree, both tails go down, negative leading coefficient, right? Or both, 4th degree makes them go in the same direction, negative leading coefficient makes them both go down. And in between, it's going to look kind of like this M. Okay, so what does that tell me? Well, it also, some other things, the -3 is where the graph touches the x-axis. So if I were to maybe sketch this out a little bit better, the graph is going to come up, touch the x-axis and turn. That's at -3. Notice the outputs are both negative on either side of that intercept. And then it comes down, goes back up and down. That gives me my M shape. And the only region that the graph is positive is between 2 and 4. Okay, so the graph itself of this polynomial would look something like this, okay, where the graph is negative in 3 of the intervals, positive in 1, touches at one of the zeros and goes through at the other 2, okay? So this inequality, the sign chart, can actually help us to get an idea of the graph as well. And we can use a graph, if we knew it, to solve an inequality, because the side in which the graph is on, the side of the x-axis, can determine then for us whether the graph or whether the polynomial is positive or negative.